Hello everyone, welcome back to the YouTube channel of Developers and Codescript. Today we are here to discuss the problem maximum set which came in recent contest of Codeforces, that is educational Codeforces round 144. So let's see the problem statement. And the problem statement is given as a set of positive integers as is called beautiful. If for every two integers x and y from this set either x divides y or y divides x. So what is that? This condition that every pair from this set S should follow either x% y should equal to 0 or y% x should equal to 0. This is the condition which this set should follow, and that is only the beautiful set. Then we are given two integers L and R. Consider all beautiful set consisting of integer not less than L and not greater than R. So integer can be in this range. Then you have to print two numbers. What are the numbers? That the maximum possible size of a beautiful set where all elements are from L to R, and that should be a beautiful set. That means what can be the maximum possible size in which the integers follow this condition and this condition, both conditions. Then the number of beautiful set consisting of integer from I to R with maximum possible size. So first of all, we want to find the maximum possible size, and then we also have to print how many sets can be of that size. Then we have to print modulo with this. So if you see for 3 and 11, then this is L, this is R, or integers can be in between 3 to 11. Then what we want? We want to choose such integers in which these conditions would follow. Then we know that this is only possible when, like, just think that this is x, this is y. Then if x is less than y, then y should be any multiple of x. Y should be any multiple of x. Then only this condition can be true. Like if x, y, z is there, and I'm writing these in ascending order, like x is less than y, this is. Then y should be multiple of x, z should be multiple of y. Then only this condition can be followed. So for 311, there can be one 36, can be 39, then 48, then 510. These are only four sets which are following this condition, and the maximum size is 2. So let's understand it with, like, if a L and R will be given to us. What we want to maximize the size of our beautiful set. For that we can multiply with only 2, because if we multiply with 3 and 4 and more numbers, then that will come more closer to R, and from that we cannot get our maximum length, so we only multiply with 2. Then this will be again 4 and 12, this will be 8 and 12, this will be 16 and 12, and till our R. So just think that in our particular example we can only write till 16 and 12. Why? Because 32 and 12, this is more than R. So how to find this number? That we only can get 16 and 12. What I am saying here, that 16 and 12 is less than or equal to or R, and 32 and 12, this is more than or R. Then uh, from this, R upon L will be more than 16, and from this, R upon L will be less than 32. If I say it like term, then what can be the range of our term? That is, it can be ranges between 16 to 32. So 16, 17 until 31. So how to find 16? That is, total bits in these numbers are same. And what is that? For 16 that is this, for 17 that is this. So if we calculate total bits in these numbers, and what is the formula for counting the bits? That is log 2 number plus 1. This is the total bits. So 1, 2, 3, 4, 5. So for 16 that will be 5. And if I do bits minus 1, this will give us their number. Like if I do 1, 5 minus 1, that is 4. So this will be this, and this will give us 16. So what I will do? I will calculate our term, that is R upon L, Then this is the number between 16 to 32. So I will, for this a particular example, so I will calculate total bits in that number. That will be log 2. Just call it this, and the total bits will be bt plus 1. And this will be our first answer. That is, what is the maximum size of line. As we can see that in for case of this 16 one, that is total value of bt plus 1, that is 5 total bits. And here also we can see that 1 2 3 4 5. So this is our first answer, that total bits, and that is bt plus 1. And what is bt? That is log 2 term. And what is term? That is r upon r. So we have found our first answer, that is this. And now we want to find that how many sets we can make which are beautiful set, as well as their length also should equal to n1. So in our first consideration, we take that l 2 into l, 4 into l, 8 into l, and 16 into l. This is the most optimal answer for this, for making the maximum size. Or what we can do instead of this, we can do like, instead of multiplying with 2, we can multiply with 3. We are multiplying it 2 2 2. If we multiply it with 3 and then again 2, okay, 3, then this will be 6, this will be 12, and this will be 24 into r. This can be also a possible condition. Then instead of this, I can multiply it with 3. So this is 2, this is 3, this is 2, this is 2. That will be 2 into r, 6 into r, then 12 into r, and then 24 into r. Then this can be 2, this can be 2, this can be 3, and this can be 2. So that will be r, 2 into r, 4 into r, 12 into r, and 24 into r. And then this can be 2, this 2, this 2, and this 3. It will be l into 2 into l, 4 into l, 8 into l, and 24 into l. So this can be a condition that the one condition can be, we all multiples we take only 2's. Every time we multiply with 2. There can be another some condition in which we are multiplying 1 times with 3 and remaining times with 2. There can be a condition in which we are multiplying 2 times with 3, but is that can give us a maximum size length. So just think for l multiplying with 3, then again with 3. So this will give us 3 into l, and this will give us 9 into l. But we have seen that this will give us 2 into l, 4 into l, and 8 into l. Here we are getting 8 into l in our fourth number, and here we are getting 9 into l in our third number. So that have reduced our maximum size. So we cannot multiply 2 times 3. So for multiplying with 3, there can be only one condition, that we are only multiplying 1 time with 3 and the remaining time with 2. What about if we multiply with 4? So if we multiply l with 4, then that will give us 4 into l. And again same thing happen here, that is 2 into l and 4 into l. Here we are getting third number is as of 4 into l, but here we are getting our second number. So that also has reduced our maximum size, so we cannot do this also. So there can be only two conditions. One, all times we multiply with 2, and second condition can be that one time we multiply with 3 and remaining time with 2. There can be only two conditions. This is only for if we are starting from L. There can be we are starting from L plus 1, then this is 2 into L plus 1, then this is 4 into L plus 1, and so on till we can get our answer. So for 16 interval, as we have seen that how to find out this number, that to, how to find this number, till then we can get our answer, that that will be this. Where is that? First of all, count r upon r, that will be 10. Count bits in this, that is bt is equal to log 2 into 10. Bits, total bits are bt plus 1. And if we do this, that will give us this 16 in this. So if we want to find that if we multiply every time with 2, then what can be our last number? That will be this. If we multiply with every time with 2. So just call out g is equals to 1 bt. This will give us this. Then we have to check that is this is also in our range. That is, so if we want to find that, then if we compare these two, then what we can get, that if we multiply it with 3 and divide it with 2, that will give us this. Why? Because here one time we have multiplied with 3 instead of 2. So for that I will multiply it with 3 and then divide with 2. That will give us 24 and 12. So if we want to find that is this r coming in our range, for that we can do that, multiply gc with 3 and divide with 2 and just check that if this is coming in our range. Is this less than r? So if this is coming in our range, okay. So if this is coming in our range, then how many times it will increase our count of sets? That is this. That first we are multiplying on our first person with 3, then our second, then our third, then our fourth. And what is that? That is bt, because value of bt was 4 in this case. So if that is coming in our range, then we will increase our total answer with bt. And if this, what is that? So for if we are checking for all times with 2, then we will check over just because that is only for L. If you want to check that is L plus 1 or L plus 1, L plus 2, then what you will do? What is that? That is 16 into L. What you will do? Just consider all with X. We will check is 6 GG into X. If this is less than R, then we will increase our total answer with plus 1, because for multiplying all times with 2, that is only increasing one time. And if this, that is gg into 3 divided by 2, this with x, this is less than r, then we will increase with bt. So there can be a brute force this for this, that we increase our x from l to r and check every times for this, and we will finally print our total answer. But if we see our question, then here value of t is 10 to the power 4 and L and R ranges from till 10 to the power 6. So t is 10 to the power 4 and L and R is 10 to the power 6. So obviously that will give us a TLE. So we cannot do that. Instead of that, we can use binary search. What we can do, that just think that if any number following this condition, then obviously all numbers before that also will follow that condition, because for that x will be less than this mid. So that will follow this condition, and more than this number will not follow that condition. So we will check from binary search that what is the maximum possible number which is following this condition. Just think that that number is like mid one. Then what we will do? We will this. subtract mid minus L and plus 1 from this mid one. That will give us total numbers from L to mid one which are following this condition, and we'll update our total answer with this mid one minus L plus 1, because that's are all numbers and every time we are increasing with 1. And in this condition, for checking this condition, we are again applying a binary search and checking that what can be the maximum possible number which is following this condition, and this is the total count of numbers which are following that condition. Then we will increase our total answer with mid 2 minus L plus 1 and multiply it with BT, because every time we are increasing BT. So I will discuss a later approach which is only doing in open, like rest of O T. Then inside that we are only checking open. Here we are checking for O slogan. So first let's see the binary code. That is this. That first of all I'm counting over term. That is R upon A. Then BT. That is log 2 term. Then ans is equals to BT plus 1. That is total count of bits. This is plus 1. And that is ZZ. So I'm checking first condition. This is add 1. This is add 2. Then increasing or add 1 with add 1 minus L plus 1. And this is BT. Taking modulo and simplifying ans and total. This is the binary set solution, but this can be possible in O of 1 also, like O of t, not O of 1, but that is only for using for test cases. How can that can be? What we are doing, we are checking that what can be the maximum possible number which is following this condition. For that we can calculate value of R upon Gg. For that we can calculate value of R upon Gg, and this will be the maximum possible number which is following that condition x. And for this condition, what is that? That is Gg into 3 upon 2 into x should be less than r. From this, if we calculate value of x, that is r upon Gg into 3 upon 2, that will give us the maximum possible number x. So we don't have to use the binary search. We can check this in open. For that, we are doing that r upon Gg. Okay, sorry. This is value for x. Multiply it with 1. So I'm doing that here. Okay. I'm checking calculating or add 1 with r upon Gg, and this is r upon Gg into 3 by 2. That is same as I have written here, both r upon Gg and r upon Gg into 3 by 2. This is add 1 and this is add 2. Then in final I am not changing anything. Multiply with that bt, and that is our answer. So the code was not so much complex, but only the explanation was a little bit tricky. So I hope you all understand it. See you in the next problem. Till then, happy coding. Bye bye.